For our first example, we are going to be plugging in values to make our tables. I have 3x minus 4, so as I enter in, I'll do 3 parenthesis, plug in a 1, minus 4, plug in a 2, plug in a 3, 4, and a 5. Now I'm going to plug in to this equation, negative 2 parenthesis, plug a 1, plus 6. Scroll through, make it a 2, 3, 4, 5. I look for the point where they share a point and circle it. So then the intersection would be at 2, 2 based off of the table. For the next example, I have 3 times x minus 5. I'm going to plug in a 0 for x. Scroll through, plug in a 1, 2, 3, 4. Now I'm going to go to this equation. I'm plugging in a 0 plus 1. One plus 1, 2 plus 1. Then I look for where they share the same point. Oh. Don't share, nope, nope, right here. So the intersection was at 3, 4 on this second example. For the set section, you will be determining if things are true or false. An explicit function will add the same number each time. So you have to remember what explicit means. Explicit means like f of x equals mx plus b, which would be an example of adding every time. But another explicit was the exponential form, which was multiplying. So this is false. Because exponential or geometric explicit functions multiply or divide by the same number each time. So that would contradict what they were saying. It doesn't add every time. Explicit could be add, subtract, multiply, or divide. An arithmetic sequence, that's the adding one, has a common ratio. So it is actually not the ratio, it is a difference. Has a common difference. So this one was false. And my correction is right here. And C says every linear function has a y-intercept. So I'm just going to graph because I like a visual. Now, if I were to draw a line this way on a diagonal, it would have a y-intercept. If I drew it this way, it would have a y-intercept. So no matter where I tilt it, it's going to have a y-intercept. There are two other cases. My line could go like this. There's no x-intercept, but it does hit the y. And then I have one other special case. It could go this way, it could be vertical. This one has no y-intercept. It only has an x-intercept. So every linear function has a y-intercept. This is false because a vertical line has no y-intercept. For the Go section, we will be reviewing domain. That means we'll be looking at x values, -4 to 0, 1 to 3, 4, and 5. So the reason I fill those in is because as I look along the x value, the domain is from -4 to 0. Then there's a gap, and it goes from 1 to 3, gap, 4 to 5. For this domain, oops, I did something weird. Because there are closed dots, I need to fix these. Closed dots are included, so we're going to use the brackets rather than the parentheses. For the domain on this one, the arrows means it will continue on in both directions, which would mean -infinity to +infinity. This one's domain, the left side, the -infinity, goes on because of that arrow, but on this one it stops at 1, 2, 3. It stops at 3. Excuse me. And because it's an open dot, it'll have a parenthesis on it. If it had looked like this, with the dot closed, it would have been -infinity to 3. And last one, domain. It's at 1 and it's an open dot, or let's see, 1 is the range, x is 0, and it goes on forever, so 0 to +infinity. If it had been a closed dot and curved, it would be 0 to